Okay, so I actually tried to record this video a few times already, but like the last take I forgot. The last good take I forgot to save. So here we are looking at question 141 linked list cycle at this timing. So given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed in as a parameter. So we want to return true if there's a cycle in the linked list, otherwise return false. Yep. So we're given 3 examples. Example 1, we can see that there is a cycle because after the last node -4, it cycles back to node with node value 2 at position 1. So we want to return true. And then example 2, there is a cycle as well because after second node, it cycles back to the node at position 0. So we return true. Example 3, we can see that position is -1, so output is false. Here are some constraints. The number of nodes in the list is in a range 0 to 10 to the power of 4, and the node value ranges from -10 to the power of 5 to 10 to the power of 5. Pause 1 can take on 2 types of values, either -1 or a valid index in the linked list. So there's a follow-up they gave us here. Can you solve it using constant memory? So this is like also a hint, I suppose, that we can come up with a solution that just makes use of constant memory. Okay, so this question is like detecting cycles in a linked list is more of a technique question, I feel, rather than a really like a logic kind of question. So maybe we can just jump right into it, the solution. So for this kind of questions, we can actually make use of the fast slow pointer approach to solving this question. So if you're unfamiliar with that, basically what it means is with the fast pointer, we step it faster than the slow pointer, usually 2 steps ahead. In this case, we can let's just use example 1 to demonstrate. So we denote fast pointer with a positive sign, plus, and slow pointer as the negative sign. Right, so first step, fast pointer moves 2 positions up to this node, and slow pointer moves here. Step 1. Step 2, fast pointer moves here, slow pointer moves up 1. Step 3, fast pointer goes 1, 2 to this position, and slow pointer moves up, and they meet at the same node. So our returning condition to return true will be when this fast pointer and the slow pointer meets at the same node. So let's just try this again and see if it works with example 2. Fast pointer, slow pointer. Okay, so first step, we go 1, 2 here, and slow pointer moves up 1. And then step 2, it goes 1, fast pointer goes 1, 2, back at the same node, and slow pointer comes here. So again, they meet at the same node, and we return true. So this will work for any of the singly linked lists with a cycle in it. So yeah, that is how we will be detecting cycles. So what happens if there's no cycle in it? Well, if there's no cycle in it, and if it's just a simple linked list, let's say 1, 2, 2, 1, and then it goes to none, we can check for the terminating condition of when the fast pointer goes 1 and then 2. So when it hits this position, or in the case if there's an odd number of nodes in the linked list, in this case it goes one step and it terminates when its .next is none. Alright, so let us start coding. So first we have to assign the declare the fast and slow pointers, assign it to head, and then right, once that's done, we can start writing our while loop for what was I gonna say, for this terminating condition, right? So we said how it should terminate when fast p is none, or like fast p dot next is none. So it has to be this and fast p next. What we want to do inside is step fast p up by 2 steps. So to do that, we just dot next, slow p steps just by 1, and now we compare it. If fast p matches slow p, return true. So once that's all done, and we exit the while loop, it's safe to say that there's no cycles in the linked list. So we can just return false. Okay, so this was very recently submitted because, well, I took this video earlier and I didn't save it. So right, now looks like it worked. Alright, so that's it for today's video. Thanks for watching and see you again soon.